All right, Algebra 2, welcome back to the last video for the Chapter 7 summative review. I'm kind of behind the ball game. I just want to let you know, I've discovered something awesome about Kami. I can zoom in, and my handwriting is much better. You're probably thinking, well, yeah, I already knew that, but I didn't. So here we go. I'm going to zoom in a little bit so my handwriting is a little bit nicer. And we are going to start looking at number 18. Suppose, as an infant, you deposit $1,000 into an investment account with an interest rate of 5%. If you're 17 years old now, find the value of the investment if the money is A, compounded annually. So this is compound interest. I'm going to use that formula, and I don't know, I'll put V for value. That is, you start with your principal amount, your starting amount. You do 1 plus your rate over how many times it's compounded per year. We call that N, and we raise that to the N T, where T is your measure of time, usually represented by years. So here we go. We want to find the value if it's compounded annually. So it's one time a year. Principal amount, 1,000. So 1,000, 1 plus, my rate is 5% as a decimal, that's 0.05. 0.05 divided by 1 because it's compounded annually to the N times T. Now what's T? T is 17 years. So you have the 1 times 17. Use a calculator for this one. And you'll get somewhere around $2,292.02. Compounded monthly. There are 12 months in a year, so this time my N is 12. Maybe I'll write that there. So same thing. You got 1,000, 1 plus 0.05, this time divided by 12, raised to the 12 times 17 power. Once again, using a calculator, you get $2,335.52. Right around that sort of sum by rounding. Compounded continuously. For this one, we need to use E. So my function, therefore, becomes y equals, you start with your principal amount, I'm still going to call it P, E to the RT power. So here we go. So principal 1,000, the number E raised to the 0.05 times time, that's still 17. Use a calculator for that one. You'll get $2,339.65. And that's number 18, all done. Now we scroll down to number 19. The COVID-19 pandemic has peaked in Italy. The rate of new infections is decreasing by 5% every day. At its peak, Italy had 30,000 people infected with COVID-19. We want to write the equation we will use, including the variable t for time. So it's decreasing, so it's exponential decay. So I need to start with the peak, which was 30,000 people. So 30,000 times. Now we need to figure out what goes in the parentheses. That's our rate. That's our decay rate. We need to find the decay rate. It's decreasing by 5%. So that's 1 minus 0.05, which is 0.95. So in the parentheses, I put 0.95. And here we say our variable is t. So that's the equation we're going to use for the rest of the problem here. Evaluate the number of people infected after 5 days. So instead of t, we're going to use the exact same equation, but we're going to put 5 instead of t. So 30,000 times 0.95 raised to the 5th power. And that is 23,213 people. We're talking about people here, so don't forget to include your label. Now, you will get a decimal here. If you want to round that up to 23,214 people, you can. So 23,213 or 23,214, either one's fine. Now, after 10 days, same type of thing. 30,000 times 0.95, this time raised to the 10th power. And here we're going to have 17,962 people, or 963 if you want to round again. Now, evaluate for the number of people infected after 3 weeks. T is not 3. Look at what we're measuring it in. Days. Here it's weeks. So you need to do a really simple conversion. 3 weeks. That's 21 days. Because there are 7 days in a week, times 3 weeks, 21 days. Now we can do this. 30,000 times 0.95 raised to the 21st power. And we get 10,216 people. Man, I don't know why this is lagging all of a sudden, but it is. That's 10,216. Again, if you want to debate using the decimal, that's fine. All right, here we go, number 20. According to Johns Hopkins University of Medicine Coronavirus Resource Center, the first case of COVID-19 in the U.S. was reported on January 20th, 2020. On May 13th, the U.S. reported 21,030 new cases. What is the number of days since the first case was reported? Well, we can start there, May 13th. I've got 5% left. So I'm going to go grab my charger. I'm going to explain in the meantime. Hopefully you can hear me all right. So May is relatively easy to find because there's only been 13 days in May. So right off the bat, we know there's 13 days that we need to add to our total. Then we talk about January. Now, normally January has 31 days, but we start on January 22nd. So we need to take 31 minus 22, you'll get 9. So January has 9 days. So 9 days in January. And we already said 13 days in February. Or, excuse me, in May. Not in February. There are 29 days in February. In March, there were 31 days. And there was 30 days in April. April. There we go. Now we just need to add up all of those numbers. 9 plus 13 plus 29 plus 31 plus 30. You'll get 112 days. Excuse me. 112 days for number 20. Number 21. Write an equation calling the growth rate B to represent this situation. Now, here is where some of you may get tripped up. We need to pay attention to the context of the problem. On May 13th, we reported 21,030 cases. So I'm going to say 21,030 equals. Now we need to find our starting number. It's 1 because we know the first case was reported on January 22nd. First case means 1. And we're calling the growth rate B. And here, our time is right here. We call that T. That's 112. So that's the equation that we would use. Now we need to find the growth rate. Now, there are one of two ways to go about doing this one. The quickest way that I found, 21,030 equals b to the 112. It's understood that the 1 is in front of the b, but it doesn't need to be there. We raise each side to the 1 over 112th power. Now you're going to get a decimal. Do your best at rounding. I got 1.093 equals b. We cannot stop there. Now, this is growth rate. We know b is equal to 1 plus whatever the percent is. So 1 plus that equals 0.093. So 0.093 is r. As a decimal, 9.3% is my growth rate. And that's the end of the review. Thank you guys so much for tuning in. If you've got questions, let one of the Algebra 2 teachers know. Otherwise, happy studying and good luck.